Hi, welcome back to the course again. This is Muhammad, your course teacher for PETR1131. Um, so today at our course, Petroleum Production and Processing, we will go to the topic one very quickly. Okay, now you all understood, I believe, the course syllabus we have reviewed and about the whole course, like what are the topic of the whole course. So the today's topic is petroleum geology, so we'll have a basic understanding on the reservoirs, what are the reservoirs, how actually reservoirs form, and what are the characteristics of the reservoir, and how the fluids, that means like the petroleums, those actually trapped in the reservoir, and the way we detect and identify, that means like the exploration part of the reservoir, that would come to the following lecture. Okay, so first thing first, petroleum. So what is petroleum? So as it says, like the petroleum is a substance that occurring naturally in the earth. That means it is a natural element. It's not something derived in labs or anything. It could uh, occur naturally. Okay, so how it occur, like how we can determine, like the petroleum actually form, or what is the composition of the petroleum. So petroleum, it's composed mainly of hydrocarbons, chemicals, like hydrogen and carbons. Those are the hydrocarbons, and there is some that's the major component, but we can have some other elements, like impurities, for instance sulfur or anything. We'll come that to later. Okay, it can occur as a solid, liquid, and gas. We all know, like the coal is an example of solid, and crude oil. Okay, that means the gasoline, that's an example of liquid, and natural gas like methane or ethane or even butane. Those are the example of gas. Okay, so as I said, it can contain some impurities also sometimes, like some types of like metallic or non-metallic elements, for instance oxygen, nitrogen, sulfur, and some other trace materials. Okay, and it can be flammable, of course, mostly. Some of them are not. Like when the carbon chain actually grow higher in number, okay, we can may not be flammable. Okay, it can be composed single hydrocarbon, which is more flammable, or to a mixture of hydrocarbons. Okay, so like what is an example of a single hydrocarbon? Like methane. Okay? That's a single chain. Or even like if you mix, like for instance crude oil, it's a mixture, right? It got variety of different hydrocarbons mixture in one component. So it can be a single hydrocarbon or a mixture of hydrocarbon. Now, origin of the hydrocarbon, or like the origin of the petroleums. So there are two different theories. One is the organic theories, and it says the oil created by carbon-based life form, which is eventually moved deep into the earth. For instance, like the dinosaurs. Okay, so we had like the Jurassic era. We had dinosaurs in millions of years back, but when they all die eventually, and the earth Earth had it's terraformed. At that time, it went back under the earth, and what's happened, like under huge pressure of the earth, and without the presence of oxygen, it transformed to hydrocarbon. So that is the main base of the organic theory. And there is some there's the inorganic theory too. It says like the oil has been there, like in the earth, and it has been formed, much like the other minerals and metals. But the organic theory, it is the most convincing theory. One of the example is in many cases in the sites like the oil and gas sites, we actually got lots of fossils. Okay, so the fossils, the dinosaurs, and many other fossils. So that actually give a bolster to the organic theory over the inorganic theory. So that is the origin. Now, um, where it petroleum, like where it actually where we can find the petroleum. So definitely we can find it in Earth, and the petroleum production to not sit in an underground vault or bubble. It moves. Okay, it's just it produces somewhere, and it just moves like all other fluids. So how it can move? So what's happened? Petroleum actually lies inside a type of formation, a rock formation. Okay, just like the sponge. Maybe many of you have used when you actually try to if any water spills. So what we can do, we can just throw some absorbents. Okay, for instance, like the sponge. And what that sponge do, that sponge actually absorb the water. Okay, how? Because the sponge have a unique property. And how the sponge got the unique property? Because the sponge got some important characteristics. We call it porosity and permeability. We'll come that to later. Okay, so this is how usually like the petroleum lies inside the rock. Now, how does the earth actually, like how it actually uh, work? Let's see that. So um, let's learn about the earth's geology at first, and then we can actually have a broader version or broader picture. Okay, how this thing works. So um, the earth, we have plates plates underneath the land area of the earth. Okay, so in theory that describes the movements of earth's crust. We call it continental drift. Okay, so this earth's crust is floating on a liquid called, and that we called magma. Okay, so oh sorry, so the earth crust is floating on a liquid that called magma. I think like it's missing over here. Sorry. Okay, now a long time back, like billions of years back, the whole earth, there was no continent, like the whole continent and everything within one point. And there's a supermassive continents altogether, and that's we called Pangaea. Okay, so this is how it looks like. So this is the ocean, the huge ocean, and the Pangaea was like that. And then what's happened, it got the plates underneath, and due to that it moved, it separated, moved, and drifted around. And that's why we have seen a lots of like varieties we have. Okay, and these are the plates. So this is the Eurasia, the North America, the Africa, Southern America, Antarctica, India, the Australia. So all were together. And what's happened? It disintegrated and it moved around, drifted around. Okay, so after it's drifted around, then we have the world shape, something like that. But as I said, the plates were in there. Okay, so still we have those plates. Now you could see, like, I mean, this is the geopolitical border of the country, but the plate is bigger. So what is those other areas like that? Probably it could sink to the under the ocean, so that's why it happens. That, as you can see, okay, so this is the whole plate, but we have the land area. It's like that, the Eurasian. Okay, for instance, African plate, okay, or the Arabian plate. So this African plate is massive. It went till under the Madagascar too, but most of the portion is under the ocean, like, like half of the portion, and half we have above the ocean, like that. So these are all the plates. Okay, we have now. I will come to that later. So what are these plates? These plates actually look like the crust, like a pizza crust on the earth. Okay, so let's show you how the earth's crust could look like. So like that. So this is the crust. Okay, so these are the crust of the earth, um, just like the mud crusts. Okay, when you actually see the mud, probably you all have seen, like if a pond or a river actually dries up, then what's happened? It creates crusts on the shore, right? So exactly the same thing, exactly the same concept on the earth. At the top of the earth's surface we have this crust, but the only difference is, like, these are huge. So what's happened, these crusts, you can see there's the linings here, right? There's a lining here in the crust, so the same thing, it got the linings. Okay, so these are the earth crust. Probably you heard like lots of like thing about like the plate techniques is responsible for massive earthquakes, right? So what's happened, like still this earth's crust, those are moving just like the Pangaea, so still it's moving, and sometimes they actually collide to each other, and that's why uh, the the earthquake actually happened. So probably you'll hear a terminology that says like the uh, earthquake prone zone, right? So you know which area in the world got most of the earthquakes. Let me show you. Like, for instance, California, this area is known for massive earthquakes. Why? As you can see, there are Pacific plate, Juan de Fuca plate, and North American plate. So three plates are in here, so always the plates moved, and that's make the whole Los Angeles, California, this including the British Columbia, this area got more earthquake prone zone. Okay, and for instance here the Indian and Australian plate and sometimes collide with the Eurasian plate, so that's why like the Nepal and here the Afghanistan and those areas got like more prone to the earthquake. Okay, as well as that's these places. So look at the Indonesia. Okay, the same thing, the Eurasian plate and the Indo-Australian plates get the collision, and Indonesia um, as well as you can see like the Philippines plate also got the collisions too. So these are the reasons why these areas actually got way more earthquakes. You here, like I mean, look at here, the Arabian Peninsula. Okay, so the Arabian plate and the Eurasian plates sometimes actually collide, and that also create lots of like earthquakes near this Turkish area and also Iran and those areas, right? So this is a kind of like one of the impressive thing to check, like I mean how the plate techniques determines the geology, okay, and the earth movements and everything about the earth. Now, how actually these plate techniques and these geologies actually relate to our field of interest? We'll see that. We'll see that. Okay. So what's happened when these plates actually collide and it moves? So there are lots of things could happen. Okay, it can crunch the earth's top, it can crunch, it can fold, it can like create like this shape. Okay, so there are lots of types of geological change could happen, like creating the faults. Okay, make creating the ocean ridge. Okay, so these are the things could happen, and whenever any kind of like faults create, what are the faults? Faults are like when two plates collide with each other, they create the faults. Okay, so the rising magma actually come up because we heard like what Earth's crust is floating on the liquid that's called magma. Okay, now at the deeper down, at the higher pressure and temperature, the rock tends to be more flexible. Why? Because of the high temperature. Okay, because the temperature at the bottom is very high, the rocks could be act like more like I mean flexible, and it will bend and wrap instead of breaking. What actually breaks? Something is more fragile that breaks. But if, for instance, just think about a glass. At the normal temperature, the glass will break. But if you increase the temperature nearly 500 degrees Celsius, then what's happened? The glass will melt, right? So exactly the same types of phenomena, the rocks actually could bend or wrap instead of breaking at the deeper down, at the higher pressure and at the higher temperature. Now, if the rock bend or wrap, we call it anticline. Okay, the upward bend or wrap, and the downward bend or wrap we called syncline. That means here is one is anticline and another is syncline. We'll see that. We'll see that at the next slide. This one. So which one is anticline? This top area. And which one is syncline? Here. Okay. So this is the compression. That means this is um, the rocks layer of the rocks under the earth, and we have this anticline or syncline formation due to the compression. Okay, now just remember anticline and syncline. Okay, now during the time of formation of the anticline and synclines, it can create domes. Okay, so what are the domes? Domes is a short, quick dropping anticlines. Okay, are subgrouped in a category known as dome. So dome is a type of anticline. You can see it's a type of anticline. Okay, but it got a sharp tip. So we call this a salt dome. All right. Fault. What is fault? Fault is a large or break or fracture in the earth caused by tectonic stress. For instance, in here you can find a fault. So this is a fault. Okay. So it typically happens closer to the surface, and faults can occur in many different ways depending on the angles and the forces. For instance, this is a fault. So what's happened? To opposite direction, the earth is moving, okay, one to another, and then it just collide to each other and create the fault. Okay, this picture actually gives the perfect visualization, like how the faults actually create. Okay, so there are mainly three different types of fault we have: extension, compression, and transformation. Okay, what is extension? If we have like the land has been slided in two different way, like up breakthrough and down breakthrough, one actually went up, another down. So here the fault creates, we call it extension. Now it could happen reverse, like the forces are in the same, like the incoming way. Okay, so in that case it's a compression. Okay, so this is a kind of like another type of fault could be created, and there is another like strike slip of the fault, that's we call like the transformation. Okay, so this is another type, like one go upward and another is down thrown block due to the thrust. Okay, so this is another type of compression too. So these are the example of the fault. Okay, now this is about like how the domes and faults actually creates, like what are the syncline, what are the anticline. So what we have learned, we have learned about like the wraps and folds. We have learned about like the anticline and syncline, how it actually forms. We have learned how to create the domes. So what are domes? Domes are type of anticline, and we have learned about the faults, like how these faults create. Okay, so it is a type of fracture that create due to the stress of the earth. Okay, so now we know how this geological formation changed, but how it would relate with the petroleum migration, we'll see that. We'll see that later. Now, at this section, we'll learn about categorizing the rocks. Okay, we generally have three different types of rocks. One is the igneous rock. It formed from cooled magma. Now, we know there are magmas under the earth here. Okay, now these magmas are so hot that it still stay liquid. and the temperature is very high at the bottom of the earth. But when it actually moves up to the atmosphere, like that, to the surface of the earth, then what's happened due to the our atmosphere's temperature, the magmas quickly solidifies, and that types of solidified rocks we call magmas, igneous rocks, okay, directly from the magmas. There are another types of rock we call sedimentary rock. So how these sedimentary rocks happen? So sedimentary rocks actually form from the through the compression of sediments. So what are the sediments? For instance, like the shells, bones, limestone. I mean those things. One of the example of the sedimentary rock is a limestone. Okay, and how limestone actually create under the huge pressure, the shells, bones of the different plant, marine is, or even like other materials, or for instance like the sands we see, okay, if we actually put in a huge pressure, that would also create the sedimentary rock. Okay, metamorphic rock is as you can guess by the name, metamorphism means change, okay, in Greek. So metamorphic rock is actually created, it's a change of the igneous rock and the sedimentary rock both, okay, and reformed through its temperature and pressure. For instance, marble from limestone. Another precious example could be the reform of diamond or graphites from carbon. Okay, so it would be very much clear if you go to the rock cycle, and this is a very important cycle for the course. Remember that it's a very important cycle. So let me explain you how it works. Let's start from the magma. We know what is magma. Okay, it's a liquid lava that's under the earth. Now, if actually magma got a channel and it can seep through the exterior of the earth, like the earth's surface, so right after the cooling and crystallization, it will create igneous rock, right? Okay, now this igneous rock, uh, it could actually have a weathering or erosion, for instance like high wind blow, or there is a earthquake, and these igneous rocks can actually break into pieces, and then there are lots of natural calamities. So over like a period of time, like hundreds of thousands of times or millions of years later, these igneous rocks could be sediments. Sediments means like the small particles, like the pebbles or sands. Okay, it could create the sediments, and after that, these sediments could go under the compaction or and the cementation, that's we call like the lithification process. Okay, so what is that? For instance, we have a sediment under 3 miles of the earth. So under the 3 miles of the earth, under the surface, there is a huge temperature and pressure. So what going to happen? These sediments, those will be under the pressure, and it would actually compact, okay, and it would cement. That's happened naturally, and that would create a type of rock, and that is the rock we called sedimentary rock. And why we are interested on the sedimentary rock? Because the oil actually found in this type of rock. Okay, so that's why we're more interested on the sedimentary types of rock. Now these sedimentary types of rock could undergone to the heat and pressure, okay, and it can transform to another different types of rock, and that is the metamorphic rock. And again, this metamorphic rock, if it create um, like lots of deeper under the earth, then what's happened under the huge pressure and the temperature, and if it comes near the contact of the lava, it would melt again and create the magma, and it will cool again and crystallize and create the igneous rock. And this igneous rock would melt again, produce magma, or this igneous rock also could undergo the heat and pressure and create the metamorphic rock too. And the same way, the sediments, okay, the sediment, it could go to the melting process and directly create the magma. If these sediments are hot enough, it will create the magma too, okay, if it goes to the melting process, okay, or it would go to the lithification and create the sedimentary rock. Now this sedimentary rock can also undergo the weathering or erosion and create the sediments, and after the lithification process it can be the sedimentary rock again, or it can directly melt and create magma, right? Now this metamorphic rock, if the sedimentary rocks transform to metamorphic rock, then what can happen? Then these metamorphic rocks um, also can erode and create the sediments, and then sedimentary rocks and the metamorphic rocks. So this is a big cycle, and this cycle is known as the rock cycle. Very, very important. Please remember that. Very, very important cycle. Okay. So at this section, we actually learned about the rock cycle. Okay. Now that's a video how the rock cycle actually create. I'm not going to that, but I would highly suggest you to see the video. Okay, it will actually clarify lots of your confusion. Okay, please do that. Now we were actually talking about the sedimentary rocks. Now there are some characteristics of the rock we need to know before prior. I mean, we talk a little bit more about sedimentary rock. Okay, two important characteristics of the sedimentary rock. Now we'll actually talk. So the number one is porosity, and number two is permeability. So what is porosity? Pore, or the porosity, means have the pores. Okay, like not all sedimentary rocks are created equally. Some is more porous, some is less porous, some is more permeable, and some is less permeable. Okay, so what are the porosity? Porosity is a measure of empty space in a metal, in any material, sorry. And permeability is a measure of how well a fluid can move through a material, or we can say like the interconnectivity. Okay, let me give you an example how it actually works. What is the porosity? And for instance, we have a material. Okay, we have a material, and here we have small bubble inside the material. Okay, like these are the bubbles, air bubbles. So this means this material is porous. Can you give an example? For instance, cheese. Okay, cheese is porous. It exactly look like that, right? This is a cheese curd, for instance. Now, since the bubble or the gap inside, we call this is a porous. So what is this is the porosity. So what is permeability? So permeability is something is like the interconnectivity of these pores. Like what? Like there are some other pores in here. Okay. Okay. Now what? Now, if these pores are interconnected, for instance, then what will happen? Then there is a channel, you can see. So these are interconnected. Is this interconnected? Is this one interconnected? No, it is not. Is this one interconnected? No, this is not. That means this is called the permeability. Okay, so this is called the permeability, the interconnection. All right, so what is permeability? Permeability is a measure of how well a fluid can move through the material. Just like that, given the example, this is the porous space, okay, and this is the permeable place. For instance, here, if you go to the McDonald's or any kids section, you'll find there are lots of balls and balloons, okay, in there. So what is that? You can see under these balloons, just imagine these are like the grains of the sands, okay. So what's happened from the inside, the water or any other materials, it can channel, okay, it can go and channel. So that's how we call it highly porous, okay. So the porosity, the rocks with high porosity have more space or pore to store petroleum products, okay. Now replace this one with rocks and replace the air with crude oil. You'll find it just like the in the reservoir. What's happened? Okay. uh, Permeability, as I said, the channels, okay. uh, a rock with a high permeability have more interconnection between the pores, and that's how the petroleum products can move through the rock. This one we all know in the electronics gadgets, we actually usually sometimes get that. So this one is very low permeability. Why? Because none of these are interconnected at all, okay. But this got high permeability. Now, is there any example we can have that low porosity and high permeability? We can. For instance, it could look like something like this. Sorry. It could look something like this, and the channels could be look like that. Okay, so you can see like there are no pores in here, but they are permeable. Okay, water can move through. Excuse my drawing. It's not that good, but this is permeable. Okay, so these types of permeability also can happen. So yeah. Now these are kind of like the example of the permeability and the porosity. I believe you all can actually understand what is porosity and permeability, which is very, very important. Okay, so the petroleum migration. So what's happened, given that a rock has high permeability and porosity, petroleum products will attempt to move towards the surface. Okay, and when it actually moves towards the surface, it come to the Earth's atmosphere. Now, yeah, the traps. Okay, now if the Earth actually moves from the bottom to the Earth's surface, for instance, for an example, this is the Earth's surface. Okay, I'll just paint it blue. This is the Earth surface. Okay, and here at the red zone, here is the magma or the lava. Okay, and for instance, given an example, here the petroleum has been created. For instance, here the petroleum has been created. Now this petroleum could migrate. Okay, these petroleums could actually migrate, and it can actually come to the earth. Okay, so if it comes to the earth, then what will happen? Then in that case, we will not be able to find the petroleum at all. Why? Because the petroleums could form in here, and over the millions of years it could move through the earth, and when it come to the earth's surface, it would oxidize for the earth, or it would create a natural spillage, and it will be oxidized anyway, so we'll not get the petroleum at all. But fortunately, there are some um, geological formation that actually stopped the migration of the petroleum to the earth's surface, and that trapped the petroleum inside, and the geological formation that trapped the petroleum inside, what is the name of that? The name is the trap. If anyone actually watched the Star Trek, you can know what the Admiral Akbar is saying. It's a trap. So the petroleum doesn't usually seep to the surface. It usually kept underground by a geological trap. Okay, so there are two different classes of traps. One is structural trap, another is stratigraphic traps. What is a structural trap? The structural traps are formed by folding of the layers. Remember, we were learning the faults, okay, how the faults created, and the domes and the wraps and folds. Okay, now come to the traps. Okay, so look at that. This is the anticline, this is syncline. Okay, so this is anticline and this is syncline. That means the oil and gases, those could actually is as a trap at the anticline. Okay, and remember that faults. Okay, so when the fault actually, before creating the fault, this was continuous, but after the faults create, this channeling stopped because it is cut down, okay, and it reserves all the oils. Remember this dome is a type of also an anticline trap, right? Remember, so this dome also can deposit, also can use act like a trap, okay, so oil can trap under this dome. So these traps actually saved the oil and gas inside the earth, and it stopped the migration of oil and gas at the surface, okay. So these are the example of structural traps. And what are the stratigraphic traps here? So stratigraphic traps, they are not like the structural, structural traps form due to the structural change of the Earth's surface, but the stratigraphic traps, these actually created by the change of porosity or the permeability of the rock formation. For instance, give an example. Here we have sedimentary rocks, but right above that, for any reason, we have igneous rock. Then what will happen? Igneous rock is not permeable at all, okay. Remember that when we actually learn about the permeability, remember, like the sedimentary rocks, it got more porosity and permeability, but the igneous rock, it got less porosity and less permeability. So what can happen? So these oils can trapped inside the sedimentary rock if there is a block of the by an igneous rock, okay. So the non-porous formation sealed off the top edge, and that's how these traps can be formed. So we call it stratigraphic traps, okay. And there will be a combination also, like it's not always would be structural traps or only the stratigraphic traps. In any reservoirs, like any reservoir areas, there will be different types of the different combination of the traps. As you can see, like these are like more like stratigraphic traps, but these are stratigraphic traps, these are structural traps, these are like the anticlines, salt dome, faults, and stratigraphic, okay. So that means what we have learned here, we have learned all these types of traps, like the anticline traps, fault traps, salt dome traps. These all are a part of structural traps. And here is the another different type is the stratigraphic traps, and it created by the non-porous formation of sealing off the top edge, okay. So that's how it creates. Now, how this reservoir fluid actually forms. So we'll get a detail, okay, we'll get detail, but here we'll just give a brief idea. For instance, this is a salt dome, okay, this is the anticline, and here is the cap rock, the trap that sealed off the act as a trap, okay. Now the how actually the inside the reservoir the fluids actually are due to the density change, like that's how actually it layered up. Water, especially the salt water, it got higher density than oils, and gas got lower density than oil. Then what's going to happen? The gas got the lowest density, it would be trapped at the top, and the middle, like a sandwich, the middle would be the oil, because oil got less density, it's lesser than the water, higher than the gas, and the salt water would be underneath, okay. So if you want to dig a hole and get the oil and gas, so what is the optimum position? It would be in this area. If you got here, you'll not get anything, you'll just get gas. If you dig too much, you'll get salt water, so we call those dry holes, okay. But if you get here, then this is not a gas cap. So here it is the gas cap. We call this gas cap. Okay, so this is the oil. So we can get the oil from here. Okay, that's how the reservoir fluids actually form. So what are the types of reservoir fluids we have? We have oil, we have gas, and we got water. So water present during the formation known as the connate water, and typically the water sits beneath the oil and gas which transform from the bottom or the edge water. Okay, and water may form a small film around the rock pores, and we call it wetting waters, and that cause trouble sometimes. That's why we need separation of the water and oil right after we got the crude oil from the bottom. Okay, natural gas is another types of reservoir fluids. So it usually found most in the oil field, of course, and gas is classified as free gas. Okay, it's the or the solution gas, or like the free gas. So what are the free gas? Free gas are here, and solution gas are like the dissolved gas inside the petroleum. Okay, so there's a tiny portion of gas actually goes inside the and there are a portion of oil also dissolve in the gas cap. We call those condensate. Okay, so just like a bottle of soda. Okay, just exactly like the bottle of soda, the gas filled inside the liquid. It used to burn off or flare the natural gas, and we actually got the crude oil. Okay, manipulate the pressure to keep the gas dissolve the oil for better viscosity. Okay, we'll actually get that later. I mean, about that, like, I mean, how to manipulate the pressure to keep the gas dissolve in oil for the better viscosity and for the transportation also. And it also make easier to flow out of the ground. Okay, because if you actually see here, then you can find like there's the oil gas, but this gas is in very high pressure. Okay, so if you're continuously moving this crude oil at the top, so what's happened, the gas will give the pressure from here and the water from here, so you can actually recover easily. Anyways, we'll come that later. Oil water contact line here, oil water contact line is a film where the layer of the oil meets with the layer of the water. It is important to know because we want oil, we don't want the water right now. I mean, when we are thirsty, we can have definitely, but remember that's a salt water, so we just can't directly drink that too. All right, reservoir pressure, a very important thing. I'll just touch base it a little bit, but we'll explain. Okay, so the reservoir pressure is typically the deeper you go, the greater the pressure R. If a well is naturally connected to the surface, the pressure in a reservoir is only created by fluid above it. Okay, that's called the normal pressure. So here, if a well is naturally connected to the surface, the pressure in the reservoir is only created by the fluid above it. Okay, remember, the pressure in a reservoir is only created by the fluid above it if the oil is naturally connected. Okay, as the normal pressure. That means what? That means here, if you see, this is the formation pressure, this is the pipeline. Okay, this is the mud pressure, and we'll have a reservoir pressure. Okay, so if a oil is not connected to the surface, the overlying rocks can squeeze the reservoir and create the abnormal pressure. How? For instance, these rocks, this can choke, and it could actually create the abnormal pressure. So the abnormal pressure can also occur if the rig elevation is situated below a section of the water table, which could cause the bottom of water to push up the oil. How? For instance, here is the rig, here is the oil, and the water table is in here. So then what's going to happen? You will get lesser pressure. For instance, if this rig is well above the water table, then what will happen? If you continuously withdraw the oil, the water will actually fill up the empty space and it will give a lift to the oil. Okay, but if you go actually down, then what's happened? This you remember, like the potential energy, like the height. So if the height is, this height is lower, then the pressure would be low, and there will be so much abnormality at that time. So we'll actually learn, as the course goes on, we'll learn about these things more and more. So today's lecture will actually finish up to this, and shortly now we'll have a live Q&A session. We'll actually go through that, and then we'll have we'll wrap up the class. Okay, so good luck everyone, and we'll see you shortly. Bye.